Blast off. Earth science time. Today we are talking, I got a black marker, and I thought I had a pink marker in my pocket. Well, whatever. Today we are talking about weathering. I think I did say earth science time. Weathering, erosion, and your boy soil. I'm going to do that one in a different font because I think of him differently. Oh, and by the way, is this also picking up? Can you see the little microphone ball? Okay, good. Earth science. Today's objective. What's up? It's like in the bottom right. There's like a little microphone, and there's like 5 dots, and they should be. They're getting. Okay, yeah, they're changing from grayed out to white. I should cut this because this is nonsense. But the objective that we're trying to meet is normally up there, but I can't see because your bell work was a failure. But Kendall has it. Let's hear it, Kendall. Explore. Hold on. Give me a second. Explore systems. You should write this down too. Systems of change. That sounds really, that's a good start. In, okay, capital Earths. Surface. Processes. This objective is, I would say vague or ambiguous enough that it could also and does also apply to the next lesson. Specifically today we're talking about those surface processes, weathering, erosion, and soil, although this will apply more specifically to the erosional media that we talk about next time. But for now, explore systems of change in Earth's surface processes. You know what I love about that objective?
What?
Thank you for your excellent question, Gunnar. The thing I love about that objective is that change, it's all change. The nature of all things is change. You don't even have to write that down because you know that to be true in your own life.
Yes.
Everything changes all the time. We can make this as sad as we want, but let's keep it a little bit lighthearted and say that everyone you know will die. So that's gonna happen. That's a change that occurs. That everything that exists will eventually not exist. But also many things that don't yet exist will exist. It's as it were a cycle. So some of the changes that we're talking about today are, and we're gonna, as we often do, define each of these: weathering, erosion, and soil. You should know the definition for the first one, so let's just get at it. What's weathering?
Chemical decomposition.
Doesn't have to be chemical decomposition.
The decomposition.
Okay, to become what? I don't hate the word decomposition, but that has a chemical connotation. So let's say, no, that's not right, Justice. Yes, okay, so let's say the breakdown. One of the ways that things change is that they break down. Have you ever been in a relationship that had a breakdown?
Yeah.
Oof. Yes, you have, Shanna. I remember Shanna. God bless her. That breakdown is a change, isn't it? So when we are exploring changes in Earth's surface processes, one of those changes is a breakdown. Have you ever had a cat that died?
Yeah.
That's a breakdown of the biological processes. If you have some people, I don't know what you're sentimental about, but some people are sentimental about their vehicles, and those break down. Everything, all things are passing away. The breakdown specifically of rock material, we'll just put rock. Rock, it doesn't have to be capitalized, but rock, if you're not saying a rock or the rock, a rock without a definitive is usually is referring to the material rock. So breakdown of rock as a material. No, don't put it in quotes. Breakdown of rock to form, what does it become? What is broken down rock? Sediment. So just like if you were in a relationship and that relationship broke down and now you are two separate people as opposed to one whole, one thing that the gods made perfect and in unison, and now that has been broken up into separate things, which is called a breakup. That is like sediment. It's broken down pieces of rock. Okay? And we'll talk about the sizes of sediment at some point. We've already talked about them a little bit with sedimentary rock, but that breakdown is the formation of sediment. What about erosion? If that's what weathering is anytime rock is broken down to become smaller things, sediments, what is erosion?
Oh, it's the movement.
Yeah, there we go. I'm going to put transport because I think that's fancier. But yeah, you're right. The movement of sediment. And sometimes this latter thing is included in erosion, and sometimes it's thought of as a whole different process. But I'm just going to put in parentheses, ending in deposition. So when a thing is done moving, it stops, and in the context of sediments, we call that stoppage deposition. When erosion is done, it has been stopped, it is deposited. So sediments that are moving are being eroded, and when that erosion, when that movement is done, they are said to have been deposited. A lot of times in geology we talk about the two kinds of sedimentary environments. Erosional environments where sediment is being removed or moved, and depositional environments where sediment is being deposited, where sediment is being laid down, we might say. And then what's soil?
Soil.
It's soil. Good. Okay. So some of the things that we're going to specifically talk about, if I can get myself combobulated over here, I want to not show my profile to the camera, so I'm going to get this over here. Awesome. Remember that when we talked about the rock cycle, these were part of it. Yeah? Which kind of rock did we associate with weathering and erosion? No, you're being too specific. Sedimentary rock. So sedimentary rock is largely associated with weathering and erosion. And then when that sediment, some kinds of changes are constructive, right? We talked a lot about death and breakups, and those are destructive, we might say, changes. And that is kind of a perspective. Like, you have been culturally forced into the box of thinking that death must be bad and that breakups must be bad because when things are over, that's bad. But that's not necessarily the case. However, there also are what we might, from our cultural perspective, call constructive changes, even in geology, where sediments come together and they lithify, they compact and cement and become new rock, right? So that's another kind of change. And all of these things happen on the surface. What do I mean by on the surface?
On Earth's surface.
On Earth's surface, as opposed to what?
Earth's
Inside of Earth, either in the crust, in the mantle, or in the core. All of those things we would call at depth. And so igneous and metamorphic processes are largely occurring at depth, which is under Earth's surface. But these ones largely occur on Earth's surface, so we call them surface processes. Kesslin correctly points out that there are also extrusive, we might say volcanic igneous processes, but these ones are sedimentary processes, and we call them surface processes.
I put process as.
Good job, Gunnar.
Thank you, Gunnar, for doing that. So what are some things that can cause weathering, I wonder? I wonder if you know.
Water.
Okay. Be more specific. How can water cause weathering? Now, be careful, because we are, oops, I should do this in orange. We are specifically talking about weathering, which is the breakdown of sediment. So water is a correct thing. River, you're getting, I wouldn't say colder necessarily, but you're not, I don't think you're going to hit the nail on the head with that kind of route. So water, how does water not move sediment? We will talk about that. But how does water break down sediment?
By hitting it. Drip.
What's one way that water can break down some kinds of sediment?
Flowing.
Freezing.
Okay, I'm going to put freezing. Freezing and thawing.
Everything that water can do.
Freezing and thawing, right? Remember, the idea of frost wedging is that if you have a rock, this is not a rock. This is the planet Earth. This is the literal planet Earth. I have the whole world in my hands, as we say about me. But this is probably would be the most perfect cue ball ever machined if that were. But this isn't it. But if this were a rock, and you can imagine if I had a little crack in here, I don't really want to break this thing, so I wish I had something different. Just imagine with your little imagination. Imagine this had a crack in it. Are you imagining? I don't see your eyes are closed. Imagine, please. Imagine this had a little crack in it. Look, because I want to show you. Imagine this had a crack in it, and then water could get in the crack pretty easily, couldn't it?
Yes.
Imagine water going into a crack. This is one of the things that we imagine in neuroscience. And then, if that water got cold enough to freeze, what do you know about ice as compared to the amount of, you can open your eyes?
It expands.
Yeah, ice, this is very unusual in material science. Most materials, when they get colder, get smaller. They contract. But water, when it gets colder, expands. And so that crack then gets a little bit bigger, even in something like rock. Then what happens if that water melts again, thaws? That fits further into the crack. More water might come into the now bigger crack. You guys know about big cracks, and more water could fill that in. And then when the water freezes, don't get that smile off your face. When the water freezes, the crack gets even bigger. Thaws, more water gets in, freezes, even bigger. And eventually a rock can be split by something as simple as ice. And so that's one way that physical weathering. Now, think about the differences between physical and chemical weathering. Another thing water can do is dissolve rock. Not all kinds of rock, but over time, many kinds of rock will dissolve in water. And we call that chemical weathering. The nature of the rock is changing because of the water. The chemical nature of the rock is changing because of the water. So this is an example of physical, or we might say mechanical weathering. And this is an example of chemical weathering, where now instead of rock and water, we have rocky water. Water that has rock dissolved in it. It has changed the nature of it. What else can water do to the old rock?
It can make it sad.
It can move it.
Yeah, that's erosion. We're not talking about erosion yet. We're talking still about weathering. How else could water weather? How though?
By constantly running over it.
Okay, so there's a little bit of that, of just like friction with the water. But really, I'm going to put a little squiggle next to that. But I'm going to put especially with rocky water. Like water that already has rocks in it. It's not so much that the water itself is breaking the rocks, but since the water is carrying rocks, those rocks get broken by each other with the water as a medium, what we call erosional medium. So this is related to erosion also. But that would be a kind of mechanical weathering. Are there any ways that aren't water that things can be mechanically weathered or chemically weathered, but can be broken down?
Wind.
Yep, same kind of thing. Rocky wind that's carrying rocks can hit other rocks. That process is called abrasion. It might even apply to water, but when the wind is carrying rocks, and it's also sometimes called ablation. But when the wind or water is carrying rocks, and those rocks that are being carried crash into other rocks, either that are still or being carried, that breakdown is called abrasion or ablation. What other kinds of ways can rocks be broken?
Physical.
We got some. So again, physical.
Punch it.
Okay, and human beings are what kind of entity on Earth? They're part of the what sphere?
Bio.
Yeah, biosphere. So biological weathering. So if no, Carson, just hold it. It'll be fun. It'll be a good exercise for you. If you really strong take a rock and you break the rock open, that does count. Sometimes in some sciences we're tempted to think, like in something like psychology, we might be like, oh, we can't talk to the patients or the members of this clinical trial because it might change the results. But in geology, we totally count that. If there's a question on your test that says, Marty uses a backhoe to dig out a septic tank, is he causing erosion? Yeah, we do count that. So biological. So it doesn't have to be human beings, but like insect burrow, as an example, these are examples. Insect burrow, Marty and his backhoe. Marty, backhoe. Barrett digging some sand to make a sandcastle. That's probably not weathering. I doubt that Barrett is actually breaking down rocks. Maybe, and probably some of them, but that's probably mostly erosion. So this also applies to erosion too. Speaking of erosion, what other kinds of things cause erosion? Or what are some major causes of erosion? Yeah, water. We had this list already once before when we did sedimentary rocks, but do you remember the erosional media? What are some kinds of water?
Glacial.
Okay, so yeah, glaciers. Glacial.
Ocean.
The ocean, what kind of erosion do we call that? You have this in your notes somewhere already. No, you already said it. Someone, Ty, I think you said it. What do we call that kind of erosion?
Ocean.
Marine. Yeah, sometimes oceanic, but usually marine. What if it's a lake? Do you remember that fancy word? You have this in your notes, so I would go back and look because we've already talked about this. We're going through this really fast. What kind of erosion do we say if it's caused by a lake? Had a fancy word. Yeah, go look in your notes.
Runoff.
No, don't just guess. Look in your notes.
Water.
Yeah. I have a different notebook.
I was just giving her a
Lacustrine. Thank you. If you, like it seems like 80% of you, are either too lazy to go back in your notes and look, or don't have the notes, you should be writing these down. Okay, what about a river? Ty has the list, so what is it, Ty? You're right, it's fluvial.
Yeah.
What if it's, do you remember rill and gully? We talked about this already. Rill and gully. That's a little kind of a channel formed by rainwater flowing through sediment, and then if it gets big enough that it's permanent, that's called a gully. What other kinds of water are there? I'm trying to think.
Rain, hot water.
You guys say the most unhinged things. You have the most abnormal science thoughts. What are there more things of water on that list, Ty? Okay. Okay, besides water, then what else do we have? Wind, which is also called aeolian. Aeolian. And then we had mass movement, where it moves it might have water involved, but it's largely moving primarily from gravity. In fact, all of these, and this one, are caused by what energy source? Gravity, spelled wrong. Yes, gravity, spelled right now. What's this one caused by? What's the energy source of the wind? Ultimately, it's what?
Atmosphere.
Yeah, but what ultimately is the source of energy for that?
The wind turbine.
Changes in temperature.
Gutter.
Mass.
I'm so sorry about the things you choose to say. Yes, caused by what ultimately? The sun. The question was, what is the ultimate energy source of wind? The answer is not wind turbine. There's been wind since before wind turbines. I don't know. Maybe we should write that down. There has been wind since before wind turbines.
You want me to write that down? Yeah. I know.
Oh, here's something super important that we should know. There are two really important principles that apply to all of this, especially to, let's say there's one really important principle that we apply always to erosion, to all kinds of erosion, and there's one really important principle that we apply always to weathering. The weathering one is that greater surface area equals higher weathering rate. What's the word rate mean? We're talking about the speed. Talking about the speed. It is related to the word ratio. We're talking about how fast something happens. So higher surface area means faster weather. Maybe you should write that down, Kim, instead of writing a note to your boy. The more ground up something is, the faster it will weather, both chemically and physically. The more broken up something is, the more broken up it becomes. The more times you break up with someone, the easier it is to break up with people or to be broken up with. I mean, that's a silly little analogy, but it does. The more death you experience, the easier it is to experience death. The more broken down something is, the more broken down it can become. The rich will get richer and the poor will get poorer. That's the principle of weathering. The principle associated with erosion that we want to talk about, yes? Thank you. The principle associated with erosion that we always talk about is that higher velocity of medium equals greater size of sediment transport. So for a given medium, glaciers, yes, Carson. Glaciers, I said yes. Glaciers can carry larger sediments generally than lakes. But if we're talking only about lake erosion or only about glacier erosion, within that, the faster the thing is moving, the bigger the sediment it can carry. I wish I had a different color besides pink. Oh, purple. I'm gonna size of sediment. I'm gonna do in purple. Glaciers are generally, we'll talk more specifically about this, but they can carry large, boulder-sized sediments at the biggest. They can also carry much smaller sediments, but they can carry large boulders. What size of sediment do you think oceans can and often do carry?
Big ones.
Big, generally, but at some parts of the ocean, think about like the bottom of the ocean floor, it's very, 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 very fine. So can carry big or small. That's a very useless thing to say. Any size sediment. Woo! Lakes generally.
Boat.
Sad.
You guys are saying the worst things. Mostly small size sediments. Rivers, it depends on the speed of the river, but large, I'm going to put medium. Rill and gully, medium. Wind, usually small. There are exceptions. And mass movement, any kind of like rill?
Yeah.
I just said that.
That's it all.
I just said. Now, pretty soon I'm going to erase everything except for the black, and we're going to talk about soil. Do you have questions? The most important things I would say to remember, this is all details, but me, with your help a little bit, not very much, presented examples, first details, and then we came up with the large overarching phenomena that explain those details. So probably the most important things to remember are greater surface area either equals higher weathering rate for weathering, and higher velocity of medium is higher or larger size of sediment. We might also say higher energy, although velocity is not wrong, so I shouldn't have crossed it out, but we could also say the higher energy erosional media transport larger sediment.
You know what I just found out?
Okay, no I don't. I'm not going to talk with you about it right now. I'm going to leave the orange and pink box up there, but I'm going to erase the rest of it so we can talk about soil. So tell me about, what is soil? I already asked you what is soil, and the answer that came back resounding from the masses was soil. That you just said the word again, which is really not a very, I wouldn't say that's a great way to define soil. Okay, wait, hold on. Someone said, I'm going to do some different color. Green. Good, okay. So soil is a mixture, right? There's not one set composition elementally. That would make it a compound, right? H2O is a compound. The soil is a mixture with not a set ratio of things. A mixture of earth materials, including, let's list some things that it can include.
Dirt.
I wish you hadn't said that, because that's not a good thing to say. That's a worthless word. Dirt is a worthless word. Dirt could be anything. Okay, sediment. So let's put sediment.
Dang, I said that.
Sediment. I'm going to put any size, although if we had boulders in it, we'd probably just call it a boulder. We wouldn't say, oh, look at that, dirt has boulders in it. Any size of sediment, which is a size of sediment. I'm going to put organic matter. Dead or alive. Another beautiful principle of the breakdown of what we might call the increase in entropy or chaos. One beautiful thing of that, people don't really like to think, especially as I say before in our culture, people like to think about life and ignore death. And they like to think about joy and ignore sorrow. And they like to think about light and ignore darkness. But there would be no soil without dead things. There would be no life without death. They go together. Bloop. That's one. This is not going to be an Eastern religions philosophy class, but the principle of the yin yang is that you can't have alive without dead. It just won't work. You can't grow yummy living corn if you don't have dead poop to grow it in. It has to be that way. So try to figure out in your brain how to apply that to your own life. I guess don't get so worked up about getting broken up with people, whatever, or when someone dies. It's just the way it is. So these things that soil contains are organized. You have to, yeah. They are organized, usually, we indicate them in this diagram, into these different horizons. And I'm going to draw an example here, but these come in many, many, many different orientations, from none of one and all of another one to none of that other one and all of the first one. So we call this the O horizon. I'm going to make this some nice little grass on top. And here's some trees. And here's a living dog.
But he's not going to be living for much longer.
That's exactly right. That's so true. All things are passing away. Okay, so this is the O horizon, which stands for, can you guess?
Organic.
Organic. So this is the horizon where we see a lot of organic material. It's not only organic material, or at least not usually, but there's a lot of organic material in here. Maybe towards the bottom we are starting to, there's some sediments in here, some small sediments. But where is this organic material coming from?
Dead things.
Yeah, dead things and living things. There are worms in here that are squiggling around and aerating it. There are moles down here. A mole is a unit, but not this kind of mole. Or have you heard, containing 6 times 10 to the 23rd. But this little mole is probably digging a burrow to make it oxygenated. And that dog's going to step in it. But he's not going to be alive for much longer. Because what is time? What is life? Then these other horizons we label pretty neatly A, B, and C. And then your book includes this D horizon down here. I'm going to put that in quotes. I don't really like that, and I'll tell you why in a second. But the A horizon is made, it has some organic matter, but it's organic matter mixed with a large amount of, or a relatively large amount of sediment. So it's a mixture of more sediment than the O horizon. The O horizon is largely organic. The A horizon has a lot of sediment mixed in. The B horizon is mostly sediment with some organic mixed in. Very little, though. The C horizon is broken down bedrock. So it's weathered and eroded bedrock. And then the D horizon is what your book just calls the bedrock. Now, check it out. Check it out. Check it out. Minecraft will have you believe that the bedrock is the lowest layer and you can't go below that. But that is not how geology works. So throw that idiot notion out of your head. That dumb video game idiot's notion out of your head. That's not how it is. Bedrock in geology is defined as the highest layer of actual rock. The highest layer of rock. There's other rocks below that. So the bedrock is the rock that is the bed on which the soil rests. So all this we would call soil. The bedrock is the top layer of actual rock. And then there would be other layers down here. And you can break bedrock.
What?
And so the varying degrees of broken downness of that bedrock give us the different horizons mixed with some organic material at the top. Now let me do a concept check on you. On the moon, would we expect to find an O horizon?
No.
No, there's nothing O on the moon. No organic material at all. Would we expect to find an A horizon?
No.
No, because that has a mixture of organic and sediment. B horizon? No.
Yeah.
It would just be C, broken down bedrock, which we call on the moon and other bodies regolith. In fact, even here we call it regolith.
What?
Regolith, which means broken rock. Hey, if you know Greek, all these fancy magic words like regolith are actually idiots' words like broken rock. And then it's just bedrock below that on the moon. There are, depending on the ratio of these, ratio and composition of the horizons, that's not how you make the letter H, let me try again, of the horizons, give different named soil types. So you're probably aware, especially you ranch hands, that different areas have different, from our human perspective, from an agrarian perspective, we might say different qualities of soil. But the different ratios of these means different soils are good for growing different things or drainage or all other different kind of applications for human beings. And the name of those different soils, I don't remember if your book provides any. No, it doesn't. But there will be a map on your test which will tell you different kinds of soils, and you have to identify, based on this kind, this is true. Based on this kind, this is true. So there are different kinds of soil. And they all end with the suffix "sol," which is the Latin word for soil. I'm trying to think if there's anything I have missed. I know there is, but I don't really care that much about getting every single thing. I care about getting the large principles. Where, by the way, so this is on the record of the video, where should you get the other details that I didn't talk about that will fill in the gaps for you? Yeah, the book. You should. It's your responsibility to read your book. You also should be reading that as you're working on your lesson self-checks and explorations and your quiz, which are due
Tomorrow.
tomorrow.
I found out.
Bye.